Hey, it's David. What about that exam? Am I right? Oh man, so what a roller coaster. Multiple choice thing. Heads up, I want to go over the multiple choice because I actually did it also. Well, I mean, I did the practice exam too, or the coding exam. But the multiple choice, when I originally took it, I got a 12 out of 15. So I just want to set that baseline out here. There were some problems that tripped me up. I moved too fast on a lot of these, and I just kind of wanted to go over why each problem was what answer, and then we can prove it. So just starting off, the very first one is which of the following types are C? A lot of these types we've all worked with by now, but it's kind of fuzzy when you're actually looking at it. So start off char or car. We know that a string is just an array of chars, so we know we've worked with that. A double we worked with, if you can think back to not the credit card, when we're dealing with like numbers and stuff with digits or with decimal places. So we know a double exists. A triple, I don't think that's one of the original types. So looking here, integers, floats, double, long doubles. So that is not one. So triple is not one. Int, we have worked with a lot of ints, and we know that's here. So we can go ahead and check that one. Point isn't one anyways, but a pointer, so a pointer is a data type. But since this is point, that is not. And then bool, this exam took it as a data type. It is if you import standard bool in C. But if you got that one wrong strictly because you missed the bool, definitely come talk to us. If you had any questions on this, that one you could argue your case for. You'd be like, well, it's not a primitive type, this, that, but it is a type. We have worked with them in some of our projects implementing standard bool and then using true false values. So this one is which of the following, so question 2, sorry. So that's it for question 1. Let me make sure. Yep. So question 2, which of the following return true? I made some code to test this, but I just wanted to go over logically what this is doing first. 1 equals 1. That's true. If that doesn't equal true, like higher level math is all a lie. Actually, maybe anyways, who knows. 1 does not equal 1. That's false. 1 always equals 1. 5 is greater than 3. That is true. 5 is greater than or equal to 5. And this is one you can miss if you're going too fast over these. 5 is equal to 5. So it's true off of this second mark. 5 is greater than 5 is false. We know it has to be the 5 is greater than or equal to 5 that we already hit. I made this program, or I made a program just to reflect this, so we can go over this real quick. This is the code to it. It has all these, and it should print on which one is true. Now we see 1 equals 1 is true, 5 is greater than 3 equals true, and 5 is greater than equal to 3, or 5. Oh, oops, I put that in the code, but not the output. Let me do that one time, just so no one thinks I'm lying. Cool, okay. So I feel pretty good about that one. So this next one is this tests your if-else tree logic. So just remember, if is a conditional, and if that conditional is true, it goes into that block. And else then precedes it and will check any other case. So in the if, else if, that means the if fires, if the if did not fire, the else if will fire, where it also checks an addition, or a conditional. And then if that's false, another one takes over. But if that one's true, nothing in the else if tree will fire. So that's what this is testing. So we come up here at the beginning, we load it with a 5. 5 is not less than 5, so this will not fire. Else if 5 is less than or equal to 5, that will fire. Because this is an else-if tree, none of the other ones should fire. Because the other ones are all else's. So this should be I is less than 5. I come over here. I think I have question C. Yeah, question 3 matching this logic. So I'm just going to make this real quick. So I is less than 5, which is what we put here. Cool, sweet. We're doing good so far, yeah. Okay, so this question also checks that if-else tree. Because, and I think I actually missed this one the first time because I was moving too fast. But we have an if-else here, and then another if. And an if starts a whole new if-else conditional tree. So let's just go over this. We have int x equals 5, y equals 16. So the first case is if x equals 5 and y is over 26. Y is not over 26, so that will not fire. So it goes into the else statement on this. If x equals 4, that's false. But since this is an or condition and this is an and condition, we know on and conditions, they have to both be right. Where an or condition, just any of them have to return true. So x is not equal to 4, x is not equal to 6, but y is greater than -1. So this is going to go into here and print case 2. And since this is an if, not an else if, it restarts the tree and we have y equals -1 or x equals 5 and y equals 16. And we know that's the case exactly. So I'm going to guess case 2 because y is greater than -1 and these are all ors. And case 3 because these are the exact values in an or statement. So let me make that. I think this is question, let me do question 4. So I have this up, make question 4. Case 2 and case 3. So cool. Now we got that one. Moving down the line. What is the correct way to answer the second element in the array R? So I programmed this out also so we can check it. Except I use applesauce instead of R. I'll change that real quick. So we know in array notation, this is testing your array notation, that all arrays start at 0. So that means what we would think of as the first element is at index 0, and the second element is at index 2. So or index 1, I'm sorry. Second element, index 1. Almost tricked me. So this one, array 0, is going to be the first index. We know that's true. Array 1, or that one's false. Array 1 points at the second index. So that's going to be my guess. Array 2 is going to point at the third index. So that's not how I want to element or grab the second element. And array 2, that's not how you work arrays in C anyways. This would be something like a dictionary, which is a key value, and I don't think we went into that too much. Array.second with a method call. This may work on some languages that are more methods and OOP. C is not that, so, but we already know it's array 1. So let's test that over here. So I'm going to make question 5. Oopsie. Okay, there we go. I swear I program for a living. Okay, array 1, which is the second element here, because the first element is a 0. So we got it. So it is array 1. Arrays in C automatically resize based on the number of elements contained in the container. That is false. That's one of the main reasons that we went into linked lists, is because an array, once I initialize it here to be like 6 or something, that's its set length in C. So that's the advantage of linked lists, is I can randomly add more stuff on and take it off and resize it as I want. But in C, arrays are fixed to length. And we can actually go here. Fixed array, that's C++. Array is C, data structure, fixed size, sequential collection of elements. So that one is false. It does not automatically resize. This one, let me open up question 7 before I lose track of where I am. Okay. So, which of the following for loops will print each character in a string variable named char array? So we have 1, 2, 3 in the array. The very first one, so int equals 0, so we're going to start at the very first element of the array. I is less than char array, I++. We know working with arrays that if you don't put on a length, or it just doesn't know what to do with this. So if you would do this, it would go to, I think it compares like, it doesn't do what you expect it to do. It like compares like the first letter as a number, and then we'll print it there. I'm actually kind of curious what that does. I'm actually going to print that out. So int I equals 0, I is less than char array I++. Make question 7, let's see. Oh, yeah, that is what I meant. Thank you. Yeah, so it's just telling you like you can't compare a pointer and an integer because if you leave off any kind of indexing on an array, it thinks you're talking about the very first element in there, which is a character, and you can't be comparing that. So it's not that one. The string length int I equals 1, string length char array I++. We know it's not going to be that because arrays start at 1 or 0. So if you do that, you're going to be missing the very first element, which is this O. I equals 0, I is less than string arrays I++. So I think it's that one. Let's go ahead and put it in just to double check. 0, I is less than string length char r I++. Make question 7. Cool, so print it all out. It can't be this one because it starts at 1, so we would miss the very first one. And it's going to keep running until I is greater than the char array length. We're subtracting for I, so that'll just keep running indefinitely. This next one. So int x equals 17, while x mod 7 equals 0. So 17 is prime. So this will never fire. This condition will never be true. So it's never going to go into this. Print x, what is done. So this should print x equals 17. Because the inner part, that while loop, is never going to fire. So it's just not going to go into it. It's like an if block. I think I actually made this one too. So we can see it in action. So make question 8. Yeah, so we see just completely skips over that multiplication. Okay, so this one's a little bit different. This one's using a do while. So we know the difference between a while and a do while. I hate do whiles. Is the fact that the do makes it run at least once. And then it checks the while condition, and then if the while condition is true, it does the loop again. So here we're starting out with x equals 17. Do x equals x plus 2. So in the first time it runs through, x is 19. And then it checks the condition while x mod 2 equals 0. So that's always going to be false because you can't add 2 to a number and then mod it by 2 and it equals 0 if it doesn't already. That's just some math. Not important here because we're only working with a 19 here. But we know 19 mod 2, this is false, will not equal 0. So it jumps out, and then it prints, should be 19. So let's try that real quick. So question 9, make question 9. X equals 19. Cool. So we got that. So we're off to question 10 now. Man, we're blowing through this. Question 10. Which of the following will code print? So we have a function. It doesn't take anything in. It creates an x equals 5 and returns it. So, and then in our main, we're calling x equals 6. We're calling that function. We're not capturing what's sent back. And then we're printing x. So this function, my function here, is returning a 5, but we're never capturing that. If we actually wanted to capture that, that would be x equals whatever that brings back. But because we don't, when this prints, x is going to equal 6 because of the scope of main, and we're not capturing this scope ends, so it goes back to the scope inside main. We're not capturing what returns, so it's still 6. Let me try that. Make question 10. Cool, so x equals 6. Okay, this is the same thing, except now it actually takes in a number. So we have my function here. It takes in an integer. It makes that integer a 5 and then returns it. In the main, we're saying we have an integer called 6. We call my function with that. We never catch what my function returns. So this should still be a 6. And it's returning it, so this should work. So let's try it. So make question 11. Yep, so equals 6. Once again, if we wanted to change this to 5, you could just say x equals my function. So if I make that change, now it equals 5, but that's not how it was written. It was written like this. We can see that equals 6. Cool. Question 12. So we have this, we have a function that does not return anything. So my function now takes in a pointer to an integer, doesn't return anything, but changes that number inside the pointer. It dereferences the pointer, changes it to 5. So we have here int 6, so we're creating an integer, x, calling it 6. And we know integers, if you want to load an integer, you have to do that like ampersand x to load it in the actual space. So here we have int 6. We're sending what's inside this to my function. So now we're dealing with the actual memory location of it, or a pointer to that. And here we dereference that, so we're working with the actual memory location, changes that to 5, and then we print out what is over here at x. Because this is dealing with the actual memory location of that, this function is now actually going to change it to 5. So main creates a 6, sends the location here, we change that actual location in memory to a 5, and while we don't catch anything on the way back, because we're adjusting memory, that changes it. So that should equal 5. Let's see. Make question 12. Yeah, so we can see it does equal 5 in there. This is one of those things that you probably Just one of those things about C. We're coding in C. It's important to know what it's doing, how the difference between like stuff in memory and scope, and then like actual memory. So that's that. Which statement is false? Structures or derived data types. I think that's true. And since this is multiple choice, I can hopefully find the one that is false. Each statement definition must end with a semicolon. We saw that up here on, or we see that in a further question. We actually see it down here directly after. So this struct, they use a semicolon. So we know that's true, even if you weren't familiar with this. We're making a structure. Structure can contain an instance of itself. That is false. So that would create just a really bad memory recursion thing. C's not going to let you do that. It will let you create a pointer to itself. So you remember in the linked list how we would create a structure and then say node pointer or next node pointer and declare itself. So you can put a pointer to its own structure in there. So my guess is that. Structures may not be compared using operators, this and that. You can do that. Yeah, so you can compare all the members. I don't know if we've seen that yet, but you can do that. And we already found the one that's false, so I guess we don't even need to read these. But the tag portion of structure definition is optional. That's also true. So that's going to be like where you can name it something. None of these examples are good. No. So that's when you define it. You can also put you can have struct person this and then something after that. So we already know this one is the most false. So we move on to this question, which is 14. Wow, we are almost done. So we're creating a structure here. We have a structure called person, which holds A and B. So this function init loads A with 20, B with 30. We're creating a jimmer, and we're setting A to 9 and B to 10, and we're sending it to init. And then the printf, we're printing out A. So this here is going to be 9. So kind of going back what we were talking about earlier, the scope of init does not extend to here. So if we were working with pointers and we were dereferencing these fields, this would be changing it, kind of how we did on the int x earlier. We dereferenced it, got to that actual memory location, and changed the values there. But in here, this is all happening in scope. So when that scope's done, it doesn't return anything. So this is going to default to this one, which is going to be 9. Let me make this real quick just to double check. Cool. So yeah, we see it's 9. Sweet. Yeah, this is probably one of the reasons C is a lot trickier, is because it can all depend on if you're looking at the memory or scope. So definitely it's good to slow down with C. Which of the following points is true about linked list data structures when compared to an array? Arrays store their data together on disk, which makes them better in terms of performance. That's true. We learned that in the Harvard CS50 class. When you say, hey, I'm mallocating space for an array, you get a combined memory slot. It is easy to insert and delete elements in a linked list. So this kind of calls back to earlier how we talked about you can't resize an array, but you can a linked list. So if you wanted to resize that, a linked list is easier. Random access is not included in the typical implication of linked list. That is also true. So random access means like in an array, if I wanted element, the third element, I could just type in array, bracket 4 and grab the third element. I can't do that with the linked list that we've gone over in this class. Size of array has to be pre-decided, but linked lists can change their size at any time. Yes! Because as we went over earlier, that is what the benefit of using linked lists is in this class is arrays are fixed size and linked lists can move. So I'm going to move this over here and grade this real quick, or send it through the grader just to make sure it is what I want. And then let me make sure. I actually don't know how to check my grading. Okay, so here it is. This is the one we just submitted. So davidhenley.vu.com. As I mentioned, I took this before, and I got a 12. So we go down here, we got that one right, this one right, that one right. This is looking good. All of it's right. Sweet. So 15 points. I got 15 this time. That was pretty tricky. So don't feel bad if you missed that. I think an important part of this is to slow down, think about what's really going on in C, and think about scope and actual memory location and the types like int and stuff like that. You've done a lot in Harvard CS50, so just building on all the stuff we touched in that class. You've used a lot of this stuff. You've done our homeworks, so you're doing a great job. C's hard, but you all are doing very well at it. So I will post this, and I look forward to working with you all in the future. All right, have a good one.